Can you spot the difference between finding the LCM and the GCF? GCF, we are looking for the greatest, while if we use the LCM, we are looking for the least. And for the GCF, we multiply only the prime divisor on the left. But for the LCM, we multiply the prime divisor together with our quotient. Here is another example of the continuous division method. This time, you are going to find out what is the LCM of 10, 12, and 8. So first, let us arrange the given numbers horizontally. Write the common prime divisor at the left-hand side and the quotient below the numbers. For 10, 12, and 8, the prime number that can divide these three numbers is 2. Let us divide. 10 divided by 2 is 5. 12 divided by 2 is 6. And 8 divided by 2 is 4. Now, continue the process until all of the numbers are prime numbers. Since 5 is already a prime number, so we're just going to bring it down. 6 and 4 can still be divided by 2, so we're going to divide it by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. So we have the quotient of 5, 3, and 2. 5, 3, and 2 are all prime numbers, so we cannot divide them all. We cannot divide them. So I guess we can now multiply to find the LCM. So the LCM is 2 times 2 together with our quotient 5 times 3 times 2. And the answer is 120. So the LCM for 10, 12, and 8 is 120. Let us try another example for LCM. Let's find the LCM for 24, 20, 28, and 32. Okay, so if possible, start from the least divisor to the greatest. So the number that can divide 24, 20, 28, and 32 is 2. Let us divide them all by 2. 24 divided by 2 is 12. 20 divided by 2 is 10. 28 divided by 2 is 14. And 32 divided by 2 is 16. These numbers can still be divided by 2. Let's continue dividing. 12 divided by 2 is 6. 10 divided by 2 is 5. 14 divided by 2 is 7. And 16 divided by 2 is 8. Just bring down the digit that is not divisible by the prime divisor. But we will going to continue dividing those numbers who can still be divided. So 6 can still be divided by 2. And 8 is also a number that can be divided by 2. But 5 and 7 are already a prime number, so let us just bring them down. Okay, so 6 divided by 2 is 3, and 8 divided by 2 is 4. So we have already here 3, 5, 7, and 4. So 3, 5, and 7 are already prime numbers, but 4 is still a composite number. So we're going to divide 4 by 2. So 4 divided by 2 is equal to 2. So 3, 5, 7, and 2 are all now prime numbers. Since they are now prime numbers, so we're going to stop dividing. And we're going to multiply the number on the side together with the number at the bottom. So we have 2 times 2 times 2 times 2 times 3 times 5 times 7 and times 2. And if we're going to multiply them, the answer is 3,360. So the LCM for 24, 20, 28, and 32 is 3,360.